Hello, I'm Nick Smith from the Sustainable Nutrition Initiative. Most countries in the world have enough food to meet their population's requirements for most nutrients. But what if they had to do so without food trade? And what if they made changes to their food production? Would they still have enough? Now, while a world with no food trade is not realistic, we can have disruptions. It can be interesting to explore the extremes of how dependent a country is on imports or on its domestic production to understand vulnerabilities. We investigated this with some food system modelling in Norway with the help of some local experts. We took the 2020 Norwegian food system, so that's food production, end use of commodities and trade as it was in 2020, matched that to the nutrient composition of Norwegian foods to see how supply matched up against population need. As you might expect from a high-income European country, there was more than enough food to go around in 2020, and nutrition. Norway is a major producer and exporter of seafood, but actually a major importer of plant foods. This reflects its limited agricultural land and shorter growing periods relative to other parts of the world. So, when we completely removed imports from the system, we saw reductions in availability of many of those plant-sourced foods and associated nutrients. Around half of Norway's food mass is imported, and over half of Norwegian calories. So, removing imports resulted in insufficient availability of many nutrients. Some of the exceptions were protein and vitamin A, which are largely supplied by domestic animal source food production and were well in excess of population need in 2020. We were also interested in changes to food production patterns. The Norwegian government has proposed changes to both food production and dietary patterns. These largely target reductions in ruminant food products, driven by a desire to reduce carbon emissions. We explored the nutritional consequences of various reductions in animal source food production, including its complete removal. The reductions were most impactful for calcium and iodine supply, raising issues in all the scenarios we looked at. There were also reductions for other nutrients like protein, vitamin A and folate, and while these fell below population requirement when animal source food production was completely removed, there was sufficient buffer in the system in all of our other scenarios. So, as in other SNI research, it was the micronutrients that were of greatest concern when we look at current and future nutrient supply. They tend to fall short before the macronutrients like protein do, and they have serious health consequences when in short supply. It's important that we take time to explore and consider how changes to the food system to achieve one goal, like environmental protection, will affect other parts of the system, like nutrition.